Hi guys, today topic is non-metals. Now we are going to differentiate between metals and non-metals by using the physical properties of some of the non-metals. Now example of non-metals are carbon, sulfur, iodine, oxygen, hydrogen, etc. etc. I'm just saying here some of the non-metals like carbon, sulfur, iodine, oxygen and hydrogen. These non-metals are either solids or gas. Mostly the non-metals are either solids or gas, but only one non-metal is present, that is bromine, in a liquid state. This only one non-metal is in liquid state. Other non-metals are either in solid state or in gas state. Only one non-metal, bromine, which is in liquid state. Now we are going to see the physical properties of non-metals. Physical properties of non-metals. In the previous video, we saw first physical property, what we saw means a luster state, that shining structure state we saw for metals. Like that, whether the non-metal also having a shining surface or not, we are going to check. Yes, in non-metals, iodine, it has a very shining surface. So this is similar to metals. In metal, gold, iron, that and all, in a pure state, that iron has a shining surface, no? So that property we said luster. Like that, in non-metal, iodine have a luster property. It is in a shining state. And second property about malleability and ductability. And ductability. These are metals are very malleable and ductile metals. For example, I said gold. For metal, I said gold. We can beat it into thin sheets and we can make a wire. Such a metal is known as a malleable metal and ductile metal. Now, we are going to check this property for non-metal. So, non-metal, we are taking carbon. This carbon also can exist in different shapes. This carbon also exists in different shapes. And that different shapes are said as allotrope of carbon. And that different shapes are known as allotrope of carbon. The diamond is the another allotrope of carbon, diamond. And it has very high melting and boiling point. Next one is graphite. This is another allotrope of carbon. Graphite also another allotrope of carbon. And this graphite conduct electricity. We know metal will conduct electricity, like that. Non-metal, for example, carbon we are taking, and this carbon can exist in different shape. Okay, how metal we can make as a thin sheets and wire, like that. Carbon also exists in different shapes, and that is known as allotrope of carbon. And diamond is an allotrope, and graphite is another allotrope of carbon. And this diamond having high melting point, and this graphite will conduct the electricity. Now we are going to see what happens when metals are burnt in air. Okay, in air, what element is present? Oxygen. Sorry, what gas is present? Oxygen. So, what happens when metals are burnt in air? We are taking metal and it is going to react with air. Air, what is present? Oxygen is present. So, when metal is reacting with oxygen, what will form? Metal oxide will form. What? This metal oxide will form. Metal plus oxygen, which gives metal oxide. Okay. So, what happens when metal are burnt in air? In air, oxygen is present. So, this metal is reacting with oxygen. Then it will form metal oxide. Okay. Metal is reacting with oxygen and it produces metal oxide. Now we are going to see some examples for that. What metal shall I take? I'm going to take copper. Copper plus oxygen formulas, what O2 gas, oxygen gas. So what it will come? Copper oxide, CuO. But here 2 oxygen is present, so you have to write 2 here. So for here you have to check left hand side and right hand side, both the elements are present correctly. Here 2 oxygen, here also 2 oxygen, here 2 copper, but here only 1 copper. So I am balancing this equation. So this is copper oxide, copper 2 oxide, black color oxide. So when metal is reacting with oxygen, in here oxygen is present. So when metal is reacting with oxygen, it is producing metal oxide. Like that, copper I am taking, copper is reacting with oxygen, I am getting copper oxide. Then I am balancing that equation. If you want to see how to balance an equation, means you can see my previous videos. Okay. In lesson number 1, I am showing how to balance the chemical equation. Now I am going to take another example. Another element, what means aluminium I am taking. What is the formula for aluminium? Al. Aluminium is reacting with oxygen. Then I am getting what means aluminium oxide. Aluminium oxide. What is the aluminium oxide formula? Al2O3. Okay. Aluminium is reacting with oxygen. I am getting aluminium oxide. Now, see, balance this equation. Here 2 oxygen, but here 3 oxygen. So I have to compensate. So I am writing here 3. Now 3 2s are 6 oxygen. So totally here 3. So I am writing here 2. So totally 2 3s are 6 oxygen, and 2 2s are 4 aluminium. Here I have to write 4. Now this is a balanced chemical equation. So again I am saying, if you want to know how to balance the equation, means see my previous videos. In lesson number 1, I am showing how to balance an equation. Now aluminum is reacting with oxygen, I am getting aluminium oxide, Al2O3. So metal is reacting with oxygen, it is giving metal oxide such as copper oxide and aluminium oxide I am getting. And this aluminium oxide is also known as amphoteric acid. Oxides, amphoteric oxides. This aluminium oxide is also known as amphoteric oxides. What does mean by amphoteric oxides? These oxides having this can act with either acid or base. As this aluminium oxide is reacting with acid or base to give salt. Amphoteric oxides means with any oxides, lead oxide or aluminium oxide. This oxides is reacting with acid or base to give salt, and that oxide is known as amphoteric oxides. Amphoteric oxides. Now I will show that through an equation. Okay, I'm taking aluminium oxide. What is the formula for aluminium oxide? Al2O3. So this aluminium oxide have to react with either acid or base to give salt. So acid I am going to take. What acid I am going to take? Hydrochloric acid I am going to take, HCl. So now oxide is reacting with acid to give salt. What salt shall I get? Aluminium chloride, AlCl3, aluminium chloride, plus water molecule will be liberated. Water molecule will be liberated. So here I am 6 HCl, 6 moles of HCl I am taking. So I am going to balance this equation. 2 Al, so I am writing here 2. So totally 6 hydrogen, 3, 2, 6 hydrogen here also. So I am balancing this equation. Okay, aluminium oxide is reacting with HCl and it is giving aluminium chloride salt. Okay, plus water molecule. Again, this aluminium chloride is going to react with base to give salt. Okay, same aluminium chloride I am taking, Al2O3 plus base. What base I am taking? Sodium hydroxide I am taking. What salt shall I get? Sodium aluminate, NaAlO2 plus as usual water molecule will be liberated. So here 2 sodium, so 2 sodium here. Now check right hand side and left hand side. The numbering was balancing. Yeah, exactly correct. Now the salt name is sodium aluminate. The aluminum oxide is reacting with base to give salt. So this aluminum oxide is reacting with both acid and base, and it is giving salt. So this type of oxides is known as amphoteric oxides. What? Amphoteric oxides. Metal oxides, usually the metal oxides are insoluble in water. But some of the metal oxide will dissolve in water to give alkali. Will dissolve in water to give alkalis. Okay. Some of the metal oxides means, for example, sodium oxide. What is the formula for sodium oxide? Na2O. Potassium oxide, K2O. So these metal oxides will dissolve in water. Plus water I am adding. Water formula is what? H2O. To give alkalis. So when Na2O and H2O will react means I am getting NaOH, 2 NaOH. Like that, KOH I am getting here, 2 KOH. Sodium hydroxide and potassium hydroxide, these two alkalis. Alkalis means what? It will dissolve in water. Okay. Mostly metal oxides are insoluble in water, but some of the metal oxide will dissolve in water to give alkalis. For that example, sodium oxide I am taking. So when it is reacting with H2O, I am getting NaOH. Like that, K2O. Potassium oxide is reacting with water and it is giving 2 KOH alkalis. I said metal is reacting with oxygen and it is giving metal oxide, but not all metals. Okay. Not all metals should not react with oxygen. Not all metals. Some of the metal should not react with oxygen. For example, gold. Even at a high temperature also, gold does not react with the oxygen. Does not react with oxygen. Another metal, sodium and potassium. We know that sodium and potassium. When these two are kept in open air, it catches fire vigorously. So they are kept in kerosene oil because it will catches fire easily. So these two is kept in kerosene oil because it catches fire easily. Next, at ordinary temperature, magnesium, aluminium, zinc, lead are covered with the oxide layer or covered with oxide layer. This metal surface, magnesium, aluminium and zinc, lead, these metal surface is covered with oxide to prevent oxidation. So not all the metals are reacting with the oxygen and it is not giving metal oxide. Some of the metals is reacting. Gold at even high temperature it is not reacting, and sodium and potassium is easily catches the fire, so they are kept in kerosene oil. And magnesium, aluminium, zinc, lead, these metals surface is covered with oxide to prevent from oxidation.